All right, now we're going to look at seasonal variation and how it affects aquatic ecosystems. Sorry. So these are the 4 seasons, and in your notes, these are the orders that you should fill in that first box where it says seasonal variation. Starting at the top, you've got winter, and then spring, and then summer, and then fall. Now, at the bottom of your page, we're going to draw some of the things that go on in these aquatic ecosystems. So I would suggest that you, at the bottom of your page, draw kind of a grid, divide it into 4 equal sections, and label them one of each of these seasons. So winter, spring, summer, fall, and then we'll fill in each of those with some of the information that's in that box, but draw it out so that it makes a little more sense to you. Okay, let's start with one piece of knowledge that you need to note somewhere in your notes, and that's the idea that water is the most dense at 4 degrees Celsius. Meaning if you had 4-degree water, it would be the heaviest, roughly is the easy way to think about it, that it would be than any other temperature. So if you had 10-degree water and 4-degree water, the 4-degree water would sink to the bottom. If you had even really cold water, minus 20-degree water, if you could keep it from freezing, and 4-degree water, the 4-degree water would still be heavier and it would still sink to the bottom while the other stuff would float. So put that as a note somewhere around that table up or even up by number 4, just that water is most dense at 4 degrees Celsius. That's going to have a huge impact on what we're looking at right now. Okay, so now let's start with winter. In whichever box you labeled as winter, draw something just kind of like this, and that's going to be our body of water. Now, in the winter around here, we know that we basically have a layer of ice on the surface of the water for much of the winter. So I would draw in that layer, and we'll just label it as ice. And underneath that, we're going to have a couple of different terms that you need to know. They're also listed under summer in the text up above. But you're going to form a couple of different layers under the water there. You're going to have an epilimnion near the surface. And you're going to have a hypolimnion deeper at the bottom. Now that hypolimnion is going to be where that 4 degrees Celsius water is sitting, right? It's become heavy, it's sunk to the bottom. And this is what allows lakes and things around here to freeze on the surface, but not all the way down to the bottom of the lake. So fish and things can still live deeper in the water because that water stays about 4 degrees Celsius unless the lake isn't deep enough where it does freeze all the way through. But as long as the lake is deep enough, that deeper water will stay close to 4 degrees Celsius and won't freeze. In between the epilimnion and the hypolimnion is a break we call the thermocline. And this is just a natural barrier where the, in this case, 4 degrees Celsius water is separated from the water up above it, which is probably colder. It's closer to the ice. So above that, it might be only 1 or 2 degrees, maybe even colder depending on the water and the pressure. But that water is colder up above, and the warmer 4 degrees Celsius water sits below it. Okay? Now, in the spring, let me just erase this. In the spring, we take our same body of water, and now that ice at the surface starts to melt. More sunshine, more warm temperatures at the surface means that the water at the surface starts to warm up. Remember, in the winter, though, that water at the surface was colder water, maybe only 1 or 2 degrees. So as it warms up to 4 degrees Celsius, that 4 degrees Celsius water is heavy, and so it drops. as that water drops, it pushes some of the water from the bottom up, and we get what we call spring turnover, where the surface water and the water from the bottom part of the lake are mixing. And this is good because it's going to take water from the surface where oxygen can exchange with the water, right? It can get into there because of waves, or you're just dissolving at the surface. And then that oxygen can be carried down into the water so that fish and other organisms in the water that need that oxygen now have access to it. Because in the winter, they were just consuming the oxygen that was there. There was no new inputs, or very few new inputs of oxygen. So this spring turnover helps oxygenate the lake. It also brings some of the nutrients from the bottom of the lake up to the surface. So maybe some of the waste and the things that have been locked in the deeper parts of the body of water are now cycling around and feeding all of the depths, all the different depths and parts. So that's spring. In the summer, we end up with something similar to the winter, although in a slightly different way. So in the summer, we still have our body of water. We still have things moving around. Although now, that 4 degrees Celsius water is still sitting down here at the bottom. And it's going to stay there because everything above it is warmed up, and so it's the heaviest. So we end up back in a situation where we have a hypolimnion, we have an epilimnion, and we have a thermocline. Except for now, it's still the 4 degrees Celsius water at the bottom, but now it's warmer water on the top. And since there is no ice, because it's summer, this water can still exchange oxygen at the surface, and there can still be some cycling of that oxygen around in here as waves and motion, but typically that thermocline doesn't allow that circulation to move into the deeper parts of the water. So this surface part that is getting oxygen exchange is probably where most of the fish and active organisms are going to have to survive, because that's where the oxygen is. As the summer goes on, the deeper parts down here in the hypolimnion are going to become more and more oxygen deprived as they use their oxygen up. There's very little cycling of oxygen back into the hypolimnion, and so those oxygen levels are just going to keep dropping. So we end up with the similar layers that we do in the winter, but for a different reason. Now we have warm water on top and 4-degree water at the bottom. As we move from there into the fall, we end up with similar situation to what happens in the spring. We have our body of water. Now the temperatures are dropping, so the water that was warm at the surface is starting to cool off. As it cools off to 4 degrees Celsius, it becomes heavy, it drops because it's heavier than the rest of the water. As it drops, it pushes other water out of the way, and so this water starts to cycle up, and we get a fall turnover just like we did in the spring. Again, mixing oxygen down into the deeper parts of the body of water, which is especially good because that's the water where most of the organisms are going to need to survive until spring. This helps carry oxygen down into that water before the water freezes up and we can't do that gas exchange anymore. So that's kind of the water cycles, or the seasonal variation of that water cycle that you need to know. This is something that's very common in Alberta because we have such extreme seasons. But you wouldn't get this in other places. If you were to go to a tropical lake, the water probably never reaches 4 degrees Celsius at the surface, and so there is no turnover. The hypolimnion of that lake might stay the hypolimnion forever and be very anoxic. Where here, that cycle, every spring and every fall, we kind of circulate that water and refresh everything to get things going. So hopefully that's helped. If you have any questions about what's going on or any applications of this, please let me know. Some of you may have even experienced a little bit of that summer thermocline if you've ever gone water skiing or things like that. Sometimes that thermocline can be pretty close to the surface, and you can actually feel that your feet in the water are a much colder temperature than your upper body is just floating in the water. So especially in the spring and in the fall, that thermocline's a little bit shallower depth. But you may have at least experienced a limited amount of that. But like I said, any questions about anything in here, just let me know and I'll try to clear everything up for you. Hopefully that helps.